Hey guys, welcome back to another Math Mogul video. Today I have two example problems here that we're going to solve. The first one is the problem in white and the second one is the one in yellow. So let's go ahead and solve the first one. Let f of xy equals ln of y. Suppose a, which is a vector, equals the coordinates of 3, 4, and v, which is a vector, equal the coordinates of a vector of square root of 3 over 2, comma 1 over 2. Find the directional derivative of f of xy at a in the direction of v. First things first, we need to find df over dy. Well, let's solve that right now. So ln of y, right? Well, if we're finding df over dy, we treat y as a variable, which is lucky because y is the only variable here and there's no x. So ln of y, the derivative of ln of y would be 1 over y. And now we need to find partial of f with respect to x. And this would equal, well, there's no x's here, so this is all a constant and the derivative of a constant is 0. So x, y, and this would equal, so since we're plugging since we're finding df of dy, we would get 0, 1 comma y. And now what we can do is we can just plug in these a values for these x and y values for these two over here. Well, 0, there's nothing to plug in, so we just leave that. Let me just change my color real quick. We would just leave that as 0. And 1 over y, well, here y is 4, so 0, 1 over 4. And that is f of a. That's this. But the formula for a directional derivative for this example problem over here is this. We have to times it by this v, but luckily that's a simple thing to do, multiplying by vectors, times the square root of 3 over 2, comma 1 over 2. Well, 0 times the square root of 3 over 2 is just 0, comma 1 over 4 times 1 over 2 is, is 1 over 8. And if you add them up together, 0 plus 1 over 8, this equals 1 over 8, and that is the directional derivative, right? So this one was a fairly simple problem. You just have to find f of a, and then multiply it times this vector. Okay, now let me clear some space for us. Okay. Oops. Okay, so let's do this one now. Define f of xy equals x squared y. Let the vector of a equals 3, negative 1, and v is equal to 1, negative 3. Calculate the limit as h approaches 0 of f of a plus hv minus f of a over h. Well, first thing we need to do is plug in this a. We already know what a is, okay? So a. Well, we know a is this, so we have f of, I'll do it like this, 3, negative 1, plus h of v, so h times v, which is 1 comma negative 3, 1 comma negative 3, okay, minus f of a, which is 3, negative 1, and all of this over h. Well, let's try to simplify this first, okay? So 3, negative 1, well, actually I want to simplify this over here first. Let me change my color. I want to simplify this here first. So h times 1 is h comma, h times negative 3 is negative 3h. Okay, now we can add this to this. We can add this, so this, and we can add that to this. So what is 3 comma, negative 1 plus h negative 3h. Well, 3 plus h is just 3 plus h, or I'll just write that as h plus 3. H plus 3, comma, negative 1 plus negative 3h, or negative 1 minus 3h. Minus 3h. And that is f of a plus hv. And now we have to minus this by f of, actually, first what we have to do is, it says a is x squared of y, so that's what we can do. Since h plus 3 is x, we can do x squared. So h plus 3 squared will be h squared plus 6h plus 9, right, times y, so we would do all of this multiplied by negative 1 minus 3h. H squared times negative 1 times h squared is negative h squared. Negative 1 times 6h is negative 6h. Negative 1 times 9 is negative 9. Negative 3h times h squared is negative 3h cubed. Negative 3h times 6h is equal to negative 18h squared, and negative 3h times 9 is equal to negative 27h. So we have simplified this. Now what we need to do is minus this by f of this, and it already told us to do 3 squared times, so x squared, which is 3 squared, 9 times y, negative 9, and do this minus 9. Well, let's see, so this and this will become negative 18, so we finally have negative h squared minus 6h minus 18 minus 3h squared, cubed, minus 18h squared minus 27h over h. And now we can cancel anything out that has, we can cancel out the h's. So that would be, we'd keep anything that doesn't have an h, which is negative 18, and that is our answer. Actually, I want to cancel them out because there is something that you can do. So negative h squared divided by h would be, we'll do everything except this negative 18, okay? So negative h squared over h is just negative h. Negative h. Negative 6h divided by h is negative 6. And negative 3h cubed over h is negative 3h squared. Negative 18h squared over h is negative 18h. Right? And negative 27h over h is negative 27. So now we can cancel anything that has an h. We don't need this, we don't need this, we don't need this. So we're just left with negative 6, negative 27, and this negative 18 we had over here. If we add them all up together, we would get 6 plus 27, 33. 33 plus 18 is 51. So we get negative 51 as our answer. Right? So for the first one, we solved it. We calculated the limit using the directional derivative. And for the first one, we just found the derivative, but not the limit. So let's review our answers. For this one, it was, it was 1 over 8 for problem number 1. And for problem number 2, problem number 2, the answer is negative 51. There you go. Don't forget to click that subscribe button, click that notification bell for our latest videos, and I will see you next time.